Friends, this is lecture number 7 of mole concept. You know, the mole concept is also called some basic concepts, and this is the lecture number 7. So, in the last lecture, we studied the ideal gas equation. Here we will study STP, SATP, and NTP. So this is the agenda: STP, NTP, and SATP. Firstly, we are taking STP. STP means standard temperature and pressure. So what is standard conditions of the temperature and pressure? Here temperature 273 Kelvin and the pressure it is 1 bar. This is SI and this is also SI. These are SI. There should be no any doubt. This is SI. So standard temperature means 273 Kelvin. I am repeating again and again. Why? Because it is important. And standard pressure means 1 bar. Now friends, SATP. SATP. It is, you know, standard. Here ambient. This is the important word, ambient, of temperature and pressure. So here we are taking ambient. Standard and ambient. Temperature remains same 273 Kelvin, but the temperature is changing. Sorry, temperature is little different. Temperature is different. It is 298 Kelvin. In fact, it is coming from 225 degrees Celsius plus 273, and this is the Kelvin. That's why it is 298 Kelvin. The pressure, the value of the pressure, that remains same, no change at all. Now friends, we also same time we study NTP. It is normal temperature and pressure. Here temperature, it is same thing 273 Kelvin, but the normal pressure we are taking 1 atmosphere. This is not a SI value. This is not, because atmosphere is not SI. This is the SI and this is also SI. So the basic difference between these three, the standard temperature and pressure, it is 273, it is 1 bar. Standard ambient of temperature and pressure, it goes 298 Kelvin. The pressure is same. NTP, normal temperature and pressure. Here the pressure is 1 atmosphere. Now friends, here it was STP, and here we are taking NTP. We know here STP temperature, here temperature 273 Kelvin, here 273 Kelvin. Pressure, here is 1 atmosphere, but here is 1 bar. It is SI and it is non-SI. This is not a SI. So friends, we know PV is equal to nRT. Here we know PV is equal to nRT. So friends, what value of R we should take here when this value is 1 atmosphere? Friends, we should take the value 0.0821. It is liter atmosphere per mole and per Kelvin. What value of R we should take here? It is 8.314 joule per mole and per Kelvin. This value of R and this value of R. So friends, here apply PV is equal to nRT. P, it is 1 bar. V, we have to calculate, and it is put this value 1. Here are 8.314 and here is 273. Here the same thing, PV is equal to nRT. Here n value is 1, R is 0.0821 and temperature is 273. Friends, here pressure is 1 atmosphere. Here volume V. Here V is coming 22.4 liter. But friends, here V is coming 22.7 liters. If we convert finally in terms of liters, then this value will be 10 to the 22.7 liters. So friends, here we put the value 1. Here put the value of N1. Here it was 1 mole. Here 1 mole. Friends, here 1 bar, we should change it in terms of the Pascal. So this will be 10 to the power 5 Pascal. Because finally the Pascal is SI. Pascal is SI. It is 10 to the power 5 Pascal. Now friends, this was 1 mole. So this volume is called molar volume. Here this was 1 mole. So this volume is called molar volume. Friends, we can say that at NTP, the molar volume, the volume of 1 mole of the gas is 22.4 liter, and here at STP, the molar volume of 1 mole of the gas, it is 22.7. The difference is little, but it is very important difference. Friends, one thing you should remember, that now it is outdated concept. So 22.4 is not relevant now. 22.7 is relevant. So in the competitive exams, you should use 22.7 liter as molar volume of the gas at STP and avoid to use this value. Friends, here we should write 10 to the power 5 Pascal, because when we change this bar into the Pascal, then this changes into the SI. Here the same thing is, we should change it in terms of the Pascal. So the Pascal unit we should always use as SI unit. The conversion of the bar into the Pascal is very easy. It is 10 to the power 5. Thank you very much. Thanks a lot.